Alright, boys and girls, new lesson, last strategy that we will be learning on how to compare fractions. So let's review the previous strategies that we were able to come up with over the last week or so to compare fractions. And let's just see how you would compare 5/6 and 3/4. What strategy would you use to compare these two fractions? First of all, I want you to think about your strategies, and let's go through the list. Can we simplify either one of these? Can we divide this or anything like that? No, we can't. Do we have the same denominator? Do we have the same numerator? Are they 1 unit fraction away from a whole? All right, there's the strategy you would use from your checklist. And we know that the bigger denominator is a smaller piece, therefore it's closer to a whole. So you would tell me that 5/6 is greater than 3/4. Okay, boys and girls, we're going to compare 3/5 and 3/8. Let's go through our strategies. Can we simplify? No. Okay. Are they the same denominator? Are they the same numerator? A unit fraction away from a whole? Can we compare them to 1/2? What strategy would you use? If you said same numerator, that's correct. That means we each get 3. But knowing me and knowing you, you probably want the bigger pieces, right? So which one of these is greater, 3/5 or 3/8? So as a unit fraction, 1/5 would be a bigger piece than 1/8. So 3/5 is greater than 3/8. Okay, our next fractions that I want you to compare is 2/6, and I want you to compare it to 6/8. Think about a strategy on your checklist that we could use. We could simplify both of these for sure because they're both even numerator denominator. We could simplify. Or we could look for same denominator, same numerator. Are they unit fractions away from a whole? Can we compare them to 1/2? I'm going to use, and you tell me which strategy you would use first. I'm going to use the benchmark fraction strategy because that would be pretty quick and easy. So if this is 0, this is 1 whole, this would be 1/2, and if I had 6/6, that would go here, 0/6 would go here, and what is half of 6? 3. So this would be 3/6. So therefore 2/6 is less than 1/2. So it would go about right there. 6/8. This would be 0/8. This would be 8/8 because that's equivalent to 1 whole. And it's easy to find out what is half of 8. Divide it by 2. That would be 4. So 4/8 is equivalent to 1/2. And 6/8 is greater than 4/8, greater than 1/2, and it would be about here. So we can see that 2/6 is less than 6/8 because this is closer to 0 and this is closer to 1 whole. They're both using benchmark fractions. That's a good strategy for that one. And then let's review this strategy. Which strategy would you use to compare 2/6 and 4/6? Okay. I would use the same denominator strategy. That means they're the same size, so I want more. So 4 is more than 2, so we can see that 2/6 is less than 4/6. So let me give you another strategy. This is our last strategy we will learn. In this strategy, we are going to create equivalent fractions so that we make sure, we're going to make the two fractions that we're comparing, they're either going to have the same numerator or they're going to have the same denominator. Because those are the two easiest ways. So this is kind of cool. So let's write down this fraction right here. Excuse me. Let's compare 3/7 to 4/9. So they're not, we don't have the same denominator, we don't have the same numerator, they're not one unit fraction away from a whole. They're both odd denominators, so it kind of makes it hard to divide them and compare them on a number line to see which one's closer to 0, which one's closer to whole, because they're both really close to a half. So that would be kind of hard to use too, and I can't simplify. So how could we make these have the same numerator? I want them to have the same numerator. So watch what I'm going to do. I'm going to first change 3/7 and then I will take 4/9. Alright, so I'm going to change the numerators so that they're the same. In order to do that, I'm going to have to multiply both of these fractions by a whole fraction. And where do I get the whole fraction? I have to look at the fraction I'm changing. If I'm going to change 3/7, I have to look at 4/9. And I'm going to look at the numerator of 4. So I'm going to multiply 3/7 times the other fraction's numerator. I'm going to create a whole fraction. That's where the 4 comes from. 4/4. 3 times 4 is 12. 7 times 4 is 28. So I have created a new fraction, but it's equivalent to 3/7 using the other fraction's numerator. So what am I going to do to create a new fraction for 4/9? Think about what I did for 3/7. I used the numerator of 4. So where am I going to get the whole fraction here? I'm going to go to this fraction, 3/7, and I am going to use the 3 to create 3/3, which is a whole fraction. And I'm going to multiply 4 times 3. And what do I get, boys and girls? 12. 9 times 3 is 27. So now I'm going to compare 3/7, which is equivalent fraction is 12/28. 4/9, equivalent fraction is 12/27. So now we can use the strategy same numerator. If we have the same numerator, we want the bigger pieces. And which is the bigger piece? If you share with 28, if you have to cut it into 28 pieces, or if you have to cut it into 27. So the less is greater. So we can say that this is less. So now we can say 3/7 is less than 4/9. That was pretty cool, wasn't it? All right. Let's try another one. Let's compare, well, this is a pretty big one, 3/8 to 15/60. Ugh. Okay, that's a pretty big fraction. Yes, we could reduce 15/60. I know I can, because I know they're both multiples of 5. So I could reduce it and divide each of these by 5. But that wouldn't give me the same, well, yes it would. But let's use the multiplication way. Because this time, I won't, yes, okay. So this time I'm going to take 3/8 and I want to create a numerator of 15. So what can I multiply 3 times to get 15? Because I see a relationship. There's a relationship here. I can multiply 3 times 5. So if I multiply 3 times 5 this, I'm going to get a new fraction, and it will be 15/40. So I don't have to change this one because it already has a numerator of 15, and now this has a numerator of 15. So it's kind of like we're comparing 15/40 to 15/60. This time I only had to change this fraction. Last time I changed both of them because there was no relationship. So have the same number of pieces. You get 15, I get 15. So I want the bigger pieces. So cut it in 40 equal pieces or 60 equal pieces. Which one gives you the greater fraction? And if you said 15/40, then you are correct. Let's see if I can do another one. How about, let's see, let's take 5/20, and let's compare it to 3/10. Okay, I see that I have a relationship here with my denominator. So in this situation, I'm going to change 3/10 so that it has a denominator of 20. I won't have to change 5/20. I'm just going to change this one because there is a relationship here. The relationship is what, boys and girls? What would I have to multiply 3/10 times to get the same denominator? I'd have to multiply times 2. So 3 times 2 would give me a numerator of 6. So now I'm comparing 5/20 to 6/20. Now we have the same denominator. And when we have the same sizes, what do we want? We want more parts. So we can see that 5/20 is less than 3/10 because it's equivalent to 6/20. So sometimes, boys and girls, when the list of strategies that we go through does not work, your last alternative is to create equal fractions. Sometimes you only need to change one fraction to have the same numerator. Sometimes you need to change one fraction so that you have the same denominator. And sometimes if there's no relationship, you're going to have to use the strategy that we first used at the beginning, where we had to take each fraction and change and multiply times each other's numerators to create equivalent fractions. So there's our lesson on how we can change fractions so that they end up having the same denominator or the same numerator. We'll continue to practice. So thank you.